Welcome to Theory of Computation class. In previous videos, I gave the overall concept of decidable, undecidable and partial solvable problems. So we can able to give a solution for decidable problems and partially solvable problems. So how to solve undecidable problems? This is the major question arises because of the usage of Turing machine. So you can able to give three ways of solution for an undecidable problem. One is a Rice theorem, and the second one is a post correspondence problem, and the third one is a modified post correspondence problem. So which are shortly called as PCP and MPCP methods. So if you consider the first solution, it is a Rice theorem. The theorem says that any non-trivial property of Turing machine that depends upon a language M and that M will accept the language and that language should be an undecidable problem. So first we should consider what is a trivial property. Trivial means three properties. So what are all the three properties means a language should be empty, a language should be regular and a language should be a finite property. So if these three properties are satisfied, it is called as trivial property. Non-trivial means the opposition. So your language should be a non-empty, your set of strings should be maybe an infinite value, or it may be a not regular language. So if you consider undecidable problem, undecidable problems are comes under not recursively enumerable. So what are all the languages comes under not recursively enumerable? Empty language and diagonal language and complement of universal language. So we already know the diagram of these notations. So non-trivial property means this will not be satisfied. So how can we give a solution for this problem? So the theorem says that all non-trivial property of recursively enumerable language is undecidable. So I want to give you a solution for this problem. So let us take S is a trivial property and the language L of S which is accepted by the machine. So L of S is in the property S. That means trivial property. Trivial means it may be empty, finite and regular. So either any values which will be satisfied as empty, finite and regular, that property is called as trivial property. And I prove this notations with the encoded Turing machine M. So here LU is a universal language and the machine M should be in an encoding format. So consider the universal language LU which is accepted by the Turing machine M. Let us consider M dash which simulates the language ML. So if M does not accept W, then the machine M will go to looping state. At that situation, the output of M dash depends upon the machine ML with the input X. So consider the output of M. So if W is accepted by M, it will give S output. If M accept W, ML will also accept W. Then if you consider M dash is a simulation of ML. So there is no problem for acceptance. If W is not accepted by M, then it will go to looping state. At that situation, the output of M dash will surely depends upon ML. So we should give another input x to ML at that situation. So depending upon that x value, ML answer will be available. Depending upon that ML answer, M dash output will be varied. So this is the situation. So consider L of M dash. So this is L of M dash. L of M dash equal to L. That means it will accept it. When it will accept it, that W will accept it by M. Then it will not accept means it will not produce output. That means the machine will go to looping state. In which situation the machine will go to looping state? If the W is not accepted by M means M dash will also go to looping state. So the working principle of M dash is simulated with ML, but the machine ML is working based upon the universal machine M. So by the theorem, if you consider LU is a not recursive language. Therefore, the output of M dash is not predicted as accept, reject or looping state. So, if you consider all non-trivial properties, those non-trivial properties are surely an undecidable problems. So, this is the proof for Rice theorem. Thank you.